W5.3. This is about interference on a rope, and in particular about nodes and antinodes. The picture, in case you're wondering what it is, if you look carefully you can see there's a student standing here holding a string of fairy lights, and another student just out of the picture over here somewhere, and they're shaking the string of fairy lights and producing this lovely, what's called standing wave. So in order for interference to happen you need two or more waves, and on a rope that's achieved because the wave travels down the rope and then is reflected at the other end and travels back again, and the two waves, the one travelling in this direction interferes or adds together with the one travelling in this direction and produces this stable pattern, so you see a loop. If you shake the ends of the rope a little bit harder and a bit faster, you would get a double loop, and faster still, get a triple loop. So, a bit of terminology. The points on the rope which are stationary, which are not moving up or down, are called nodes. So there's quite a few in these pictures, so I'll mark them all with red dots. And the points in the picture where the rope is moving at its maximum, they're called antinodes. So the rope is shaking up and down like that. And in the other pictures there are also some antinodes. We'll mark all those. Okay, so they're words you have to know, at nodes and antinodes. If it helps, the node is the thing with no movement. So nodes they have zero displacement, they don't move. The waves at that point at all times have a phase difference of 180 degrees. They're in antiphase, that's why they cancel out all the time. Antinodes, on the other hand, at those points in space where they have maximum displacement, the waves, the two waves that are adding together, have a phase difference of 0. So they are both trying to pull the rope in the same direction at the same time. So they add up to a large displacement. Interference, just three key things. You must have more than one wave because you've got to have some addition going on. They have to be at the same frequency, and they have to have a constant phase difference. If you don't have these three things, then you don't get a stable pattern, and you just see a mess basically. If you shake the rope, for example, at the wrong speed, then you won't get these nice tidy loopy patterns. So 3 things to remember. Okay, more than one wave, the same frequency, and constant phase difference.